Hello everyone, I'm Jen Hammock. I'm with the Research Informatics program at the National Museum of Natural History. I've been asked to talk to you today about trait data management, which has a lot in common with other kinds of data management, so I'm going to try to focus my talk on issues that are specific to trait data. I manage trait data for the Encyclopedia of Life, and our mandate is to provide information that is representative at the species level. So we deal in assertions like this one. A given organism has adult female body length, 6.5 millimeters. Now, one thing we're not going to talk about is the taxonomic identity of the organism. That's one of those things that's very well covered elsewhere. In this particular workshop, there is a whole hour-long session entitled Taxonomic Names and Checklists, so I refer you to that. So looking just at the statement in front of you, adult female body length equals 6.5 millimeters. One thing let's talk about for a few minutes is everything that is missing from this statement. A little bit like the illustration on the left, this is the merest sketch or cartoon of a scientific fact. For starters, was this an individual measurement or a statistical summary? If the latter, how large was the sample size? How variable? When was this measurement taken? Where was it? Any information that you might provide for an occurrence data record is probably useful for a trait data record. And the more detail you can provide at this level, the closer you will come to completely describing the complex reality that underlies the cartoon. Apart from the occurrence information, the measurement itself might call for some description also. For example, the who and the how of how the measurement was performed. All of this information is well supported by the Darwin Core Data Standard. For more detail about that, check out Deb Paul's overview of the Darwin Core from earlier in this workshop. A couple of other things that apply equally to trait data as to other data: attribution. If this record appears in a published resource, like a scholarly paper or a GBIF dataset, that should be mentioned in the record, including a recommended citation format and ideally a unique and persistent identifier. There may also be other entities in the record that have identifiers available. These may include people, places, even units of measure. Incorporating identifiers into your database will make your trait data easier for machines to read and more discoverable overall. Setting all of that aside for the moment, let's go back to this extremely truncated version of the trait record. What are your options for expressing just this simple assertion? If you manage data at a species level, like the Encyclopedia of Life, you might have an attribute term called mean adult female body length. On the other hand, you might use a more general attribute term and move some of this detail to within the records. This is a typical division of detail for a data set of specimens or other occurrences. The attribute term might be body length, and then anything having to do with statistical methods, sex, or life stage would be stored within each data record. But you can use even simpler attribute terms than this. If your attribute term is length, then the part that was measured needs to also be specified within each record. At this point, each of your records requires 4 additional bits of information. The alternative to this is to have a very large vocabulary of attribute terms. Both methods work, as do all the variations in between. To give you one working example, this is what the Encyclopedia of Life does. We have an attribute term called body length, and any information for those records about the statistical method as well as sex and life stage is found within each of the records. Because we require that the attribute term specify what part was measured, we do have quite a long list of attribute terms of different kinds of lengths. I've claimed that you have several workable methods, so you may be wondering what difference it makes and how you're supposed to decide. For most data managers, the important consideration is who is your audience and what use cases are they going to have. You may be serving a specialist audience looking for data to insert into secondary analyses. You may be supporting an identification aid for citizen science. At EOL, we define our audience very broadly. We are trying to serve everyone from the curious public through learners and educators to researchers and natural resource managers. We also have a very wide subject matter base. We attempt to cover all known species with a fairly wide array of traits and other attributes, so discoverability has always been one of our greatest challenges. We need to be able to help an unknown, naive user locate what they're looking for in a very large and heterogeneous sea of data. A visitor to our data search page can inquire, for instance, about length, or even more generally, about size. The interface will give you a view of the range of different data types available for your query, and you'll have the option to narrow it down. We support this functionality using what we call parent-child relationships among our terms, where a child is a loosely interpreted subclass of the parent term. The larger your data vocabulary, the more important it is to provide this kind of navigational help. Our own vocabulary is so large mostly because of our taxonomic breadth. Starfish, mollusks, arthropods, vertebrates, and plants are measured in many different ways, and even attribute terms that sound the same can be interpreted differently by different people. For example, body length for some people means the longest dimension in an organism, but for some organisms that dimension looks more like a width or a height. In cases like that, we try to support all schools of thought, which is why you can find your way to plant height 2 different ways. Wherever you choose to stop narrowing down your search results will include records that use the term you selected and any of its child terms. One more thing. Data terms being so potentially complicated, this is another area where it can be really useful to rely on established identifiers. Wherever possible, we use existing terms from published ontologies for our data. This provides them with definitions agreed upon by a community and makes it easier for visiting machines to recognize and interpret them. This has been a quick peek into trait data management. I hope you're excited to plunge in. Feel free to contact me with any questions you have about what we just covered. If I can't help you myself, I can nearly always tell you which expert or online resource you need. Also, do hang on to the speaker list from this week's workshop. There are a lot of great resource people in there also. Happy data management.